Okay, good afternoon. My name is Darren. I'm from the data science team at Circle. So some of you might not know who Circle is, but I'm pretty sure everyone, if not, or most of you, if not everyone in this room, knows our product, which is USDC. So today I want to talk about bridging. So quick show of hands, how many people in this room have used a bridge? Okay, it's good, like six. Wait, keep them up. Okay, and keep them up if you've bridged USDC. That's like everyone. Did anyone lower their hand? Okay, that's cool. I was guessing like 70, 80%. But it's not a surprise because by volume, USDC is actually the most bridged asset. So on a typical day, around 35% of total bridge volume is USDC. This is the most, although Ethereum is also usually around there as well. And this is about daily, you're looking at about $80 to $100 million of USDC being bridged. So to give some perspective, DEX swaps using the same measures, we see about like 7 times this. So about like 14% of DEX volume you get in bridge volume. So there's like a significant amount of economic activity occurring over bridges. By wallets, USDC is the most bridged ERC20 token. About 1.8 million wallets have bridged USDC, and this is second only to Ether. So all the data you're seeing here, by the way, this is from a data set that my team and I have put together. So 50 million transactions with decoded logs covering the 9 major blockchains up there. So Ethereum, L2s, and Polygon Avalanche, as well as all the protocols you see. So along with the canonical bridges, you have like Synapse, Hop, Stellar, etc. Anyone from one of these protocols in this room? Which one? Hop? Okay, you can complain to me afterward if your data looks wrong. Cool. So before we go further, I want to differentiate between the 2 types of bridges that we think that I think of the ecosystem in. So first you have your like canonical bridges. So this is the bridges that will actually mint the token on the destination chain. So for example, you lock USDC in on Ethereum and then mint it on Arbitrum. So these chains generally get you the highest amount of security, especially with L2s, because you're basically relying on the consensus on both chains. You get one-to-one assets. If you mint 1,000 USDC on Ethereum, you're going to get 1,000 USDC on Arbitrum. It's not dependent on slippage or like liquidity. You just have to pay the gas costs. But it's only bilateral, right? Because you can only send between Ethereum and Arbitrum. So when we look at these bridges, like we see these bridges as functioning as like the major arteries for multi-chain DeFi ecosystems. So this looks at what percent of transaction volume is done by transactions over $100,000. So these are pretty big transactions. Generally, a few wallets, they're supplying liquidity to all these chains. So you're looking at canonical bridges, it's like 85, 90% of volume being done by these actors, whereas it's closer to 30, 50% for the smaller protocol bridges. So which is the other kind? So these protocol bridges, some of them do message passing and general minting and burning, but in practice, they are basically networks of liquidity that operate on either side of the blockchain. So you're swapping like for like, so USDC on Ethereum, for example, USDC.E on Avalanche or Arbitrum. And the advantage of these bridges, you get generally much faster settlement times. You get a better user experience because these are applications that developers are building. They're like dedicated developers, whereas the canonical bridges are built by core devs. So that you really get like only one shot at it. And this is multilateral. So these are all networks. You can swap between Ethereum, Arbitrum, Polygon. You don't have to like retransit back to Ethereum. And looking at like settlement timing, you can see that like the protocols are much faster than the canonical bridges. You're generally waiting a few minutes, maybe sometimes less to a few minutes, whereas using a canonical bridge, moving to the L2s, you're still going to wait 10, 20 minutes, And this is not even looking at bridging back from L2s to L1, because that adds an additional few hours or 2 days for fraud proofs. Okay. And so looking at what users are actually using these bridges, like we see a strong preference, a real preference for users to use protocol bridges over canonical bridges. So this looks at what percent of transactions are coming from the canonical bridge. And you can see that on Ethereum, like it's mostly using canonical bridges to send liquidity to other chains. But on the L2s and even on the L1s, right, like over 75% of transactions are done by protocol bridges. All right. And we also see that like users tend to come back when they use protocol bridges, right? It seems to offer a better user experience. This is just a rough, you don't have to worry about like what the numbers here mean exactly, but in general, you see a relatively higher retention when controlling for other factors when we look at wallets that are using protocol bridges. The problem with these bridges is obviously security. So we recently had a reminder of like bridge security. And according to PeckShield, over $2 billion $2 billion have been lost to bridge hackers since 2021. But we also can't not have bridges because they are like essential for moving liquidity and moving assets between DeFi ecosystems. So our solution to this problem is the cross-chain transfer protocol, or CCTP. So this is a permissionless on-chain utility that facilitates native USDC minting and burning, so anyone can use it. And we think this is a breakthrough in stablecoin infrastructure. It makes USDC natively multi-chain, letting anyone tap into it as a way to move USDC freely and securely across multiple blockchains. And we think this tries to achieve the best of both worlds, where you have the security of knowing that you're using USDC that is backed by Circle, while giving developers the flexibility of how they want to integrate it into their application or to not use it at all. So how does it work? At a high level, the user initiates access to the app, an app to initiate a transfer USDC, specifies a recipient wallet, and the protocol facilitates a burn of USDC on the source chain. Our attestation service observes this and the burn event. So this is an off-chain service. Although I promise you it's running in a cloud account that more than one user has the access to. The app then requests the attestation from Circle, which provides authorization to mint the specified amount of USDC on the destination chain. And then finally, the app uses the attestation to trigger a mint on the destination chain. So we really don't think of CCTP as competing with bridges, but as a primitive to leverage and extend. We want to make it easier to embed cross-chain transfers into any application, and so that users might already inherit CCTP functionality from an existing protocol that they interact with. So we launched CCTP for Avalanche back in May, and then Arbitrum a few weeks ago, actually. So how have we been doing? So when we look at our measure of transactions counts, around 40% of transactions between Ethereum, Arbitrum, and Avalanche are already using CCTP. The interesting thing is that like users might not even know they're using CCTP because this is really looking at the back end, like what is actually facilitating the transfer of USDC. You can also look at the front end, like what contract are users actually interacting with. And when we look at this, only around 10% are using the CCTP contract directly. The other 30% is using of CCTP usage is coming through our partners. So those include the MetaMask bridge, Synapse, et cetera. So as a developer, why should you think about adding yourself to this list? So like one reason is inflation. Not that inflation, but token inflation. So this is something that the bridges are expensive to maintain. You need to have liquidity on both sides of the bridge. And when you look at how the LPs today are being compensated, like overwhelmingly, like 90% of the return is coming from token inflation. So we're already seeing discussions within these protocols about what is like the appropriate level and use of token emissions, which pools do they incentivize and how much. So what ends up happening is like you're basically like swapping from one bridge to another is actually quite cheap, on the order of a few basis points, because the LPs are being compensated through token inflation. So if you're a token holder on all these protocols, you have a direct incentive to integrate CCTP. It completely reduces or reduce the liquidity requirements of the most bridge asset, which you can then redirect to other pools, or you can just reduce the overall level of token inflation. Another like difficulty or pain point we see with bridging is gas costs. So if you look at the distribution of transactions being sent, I'm using Stellar as an example here, but Stellar transactions, USDC transactions, by which chain they're sending to, you see like typically when sending to other chains, it ranges between $50 and $200 as the median amount. But when you're sending to Ethereum, the median amount is almost $1,500. And this is because to receive USDC on Ethereum, you need to pay a median of like $40 in gas, or $40 in fees, which is primarily driven by gas. And this is still an issue because over 60 to 70% of users who use bridges are still transiting Ethereum at some point. People are not just swapping back between the L2s. Most people seem to need some reason to go back to L1. So while we can't fix gas on L1, we have tried to build the most efficient bridge that we can. So CCTP uses 150,000 gas units. So compared to other like general message passing bridges, it's about 30 to 50% lower, although not as efficient as some of the dedicated L2 bridges. We also see it. You can also see like the higher dispersion in the CCTP transactions, and this is because we've built in, to borrow a phrase, like hooks. So this allows developers to batch other transactions into the minting transaction on Ethereum, and making it more efficient because you're able to batch all those transactions into a single one. And like ultimately, that's what we want to promote, because our success is going to be dependent on the entire ecosystem's success. And if you're here, you probably believe that like crypto will scale to millions of billions of users, and you probably believe it'll do so across multiple different blockchains. So like we're going to be in this multi-chain paradigm for at least like the near future. At the same time, like if you're going to build an application that has millions of users, like users are probably not going to be aware of which blockchain they're interacting with. So we see CCTP as a key piece of infrastructure to enable you guys to abstract out complexity for users, so they don't have to worry about, okay, which chain am I on? How do I get USDC from one place to another? And yeah, we hope that people find this valuable and will build on top of it. So I still have some time. Question? Yeah.
Thanks. So I think now that CCTP is launching, for example, on Arbitrum, we have like USDC-E, which is like the bridged USDC from Ethereum, and then like the native USDC, and there's like large amounts of both, and some sort of dApps support one, some support the other, some support both. That kind of creates a UX problem. Is there an idea of how to like tackle that in future chains where you use CCTP?
I think how do you address Arbitrum, for example? I think we tried to partner with some of the major users of USDC. So GMX is one of them. So they've started to, we're working with them to switch usage to the native USDC. But ultimately, like we have limited, like we can't just force everyone to use the native USDC. Although when we look at like how that's going, like we do see like eventually people do end up swapping over to the native USDC. And the way we incentivize that is, again, like working with protocols, working with exchanges, working with whoever like big actors are using USDC. How to do that in the future? You can talk to our PM over there, and he might have some ideas. I'm not sure what I'm allowed to say.
Thank you for the talk. So essentially, CCTP is quite a similar thing to the protocol bridges that you mentioned, because it actually still uses off-chain multi-sigs to attest the burn and then mint the things, with the exception that it does it just for one or a couple of contracts, specifically Circle contract, across different chains. So my question is how it affects the possible security surface of attack on the Circle. Is it the same set of multi-sigs used for the bridging, for the CCTP part, and for the main mint and burn essential mechanism for the Circle token? I'm
pretty sure those are separate attestation services, although they run under the same like overall cloud infrastructure. I'm not a security engineer. I can't really tell you like what additional security assumptions are introduced, but obviously it's going to be a lot less because you're already than like other services because you're already trusting us to observe mints and burns of USDC natively and to also custody the funds.
Hi. Is multi-chain still a partner of CCTP? And also, are there plans to include Phantom chain into the protocol and issue chain native USDC on Phantom?
What was the first part of the question?
Is multi-chain still a partner of CCTP protocol?
I believe they did get integrated before, 2 weeks ago. Sure, but that's like my understanding is that they're no longer operating. Is Phantom on the roadmap? Talk to our PM. Any other questions? Yeah.
So my question is maybe a bit more around the Circle strategy. So we've seen the market share of USDC going down after the DPEG, right? And so obviously this is something that will, improve the utility of USDC compared to Tether. So, I guess aiming to increase the market cap. But I was wondering, are there plans over CCTP into sort of integrating USDC into more application, driving the adoption? So do you have other plans around the around CCTP to actually make it even more sort of useful integrated into the ecosystem?
I think there are protocols like KyberSwap just today asked us if they want to integrate it. I'm not a BD guy. I'm not sure who we're talking to and who we're not, but I do suspect that we're talking to various protocols in the space to try to integrate it.
Thanks.
Yeah.
Could you talk a bit more on how a protocol might go by integrating CCTP? Would they have to deploy new contracts? How does that process look like?
I would assume you have to deploy a new contract. If you're already hooking into a protocol like Seller or Synapse, you should already just inherit CCTP automatically. But if you want to integrate with the smart contract itself, again, I'm not an engineer, but I would assume you have to deploy a new contract. I do have an addendum if there's no more questions. And so some of you, if you might have noticed, that I've been excluding Stargate from all of the data that I've been presenting. And it's because it's all airdrop farming, right? If you look at the transaction amounts over the last since April, they've gone up 100x, 20x. So just to give some, and that's a problem for us because we want to actually understand the organic usage of bridges. So one thing that we look at is when a new wallet uses USDC, we look at the first set of transactions and try to attribute what they're actually doing with USDC or try and infer their intent. And one of those categories is bridges. And before April 1st of this year, you see this it's maybe 2-3% of accounts where the primary use case is bridges. And then since then, it's been like 50% of new wallets on these chains, which doesn't make a lot of sense because like bridges are like a means to an end. You're not really, there's no real point to like bridge stuff back and forth between a bunch of chains. Another way to look at it, if you look at like all the new wallets who start using bridges and look at like how many of them over time are there, and then which is the first protocol they're using, you see these like massive spikes that are like perfectly timed to airdrops, right? Like in like the big spike recently in like April 1st, you see all these ZK Sync and Stargate wallets. Yeah, and they're like perfectly timed to Miles Deutscher. I'm not sure if I'm pronouncing that right, but that guy's tweets. But that's why I excluded all these protocols from the overall data. All right, so nothing else. If there's anything else, you can just contact me. I'm Darren at Circle, but otherwise, thank you for your time.